this is the agenda for the session.
We have a focused agenda for connectors in year 2022 and onwards. We're going to be working on two fronts on connectors. On one side, we plan to work on increasing the robustness of connectors, increasing the quality of topology that we collect and pass to OI, improve the disaster recovery mechanisms, and make sure that the connectors are highly available. We are also working with the OI team to bring up health metrics on the connector so that self-monitoring is enabled and you can get visibility into what's happening on the connector front in OI dashboards, DX dashboards and such. And eventually we'll be working towards unifying both the connectors into a single point entry. On the other front, improving scale and performance, we are working on multiple areas to optimize data processing and minimizing the data transfer requirements to only the delta one so that it optimizes the bandwidth use. We are also making some backend improvements on NAS reactive side to improve performance and also creating dashboards for connectors.
Connector basically that integrates UIM within DOI. OI connector, the latest version 1.42, its ability is to send the UIM alarms which are generated from the different probes in the UIM arena, and also it sends the metrics to the OI. So now it has two responsibilities. Earlier versions, we used to send inventory and we used to send groups and other information. But with the latest version of OI connector, we send only alarms and the metrics to OI. This probe is primarily works on the hub queues created on the primary hub. So when you install a probe and start the probe, it automatically creates a queue and subscribe to the required subjects. Like in case of alarms, it's an alarm update, alarm new, and the alarm delete. And in case of metrics, it subscribes. It actually creates a queue, AXA cause queues based on the cause message subjects, which are even our data engine subscribe to it to store the cause messages into our DB. So this probe primarily works on the queues, and it also accesses the database to fetch the information related to the CA hierarchy or the computer system related information, which it uses in the cache to enrich an alarm or the cause message, which is read from the hub queue. Because like if you have noticed our alarm messages in the Dr. Nimbus, it will not have all the fields that are requested or required by the OI. So basically we'll read the alarm message and then we'll enrich an alarm message based on the information available in our DB and then send it to OI. This is the architecture of OI connector. Till 1.42, we used to recommend the OI connector to be deployed primarily on the primary hub and any robot attached to the primary hub. With the latest certification, we made OI connector available on the secondary hubs too. Basically, you can just read the messages which are generated from this. You can basically deploy multiple OI connectors on a secondary hubs that will do the same job of the prime, like one OI connector reading messages from all the hubs and then sending this data to OI. You can basically load balance your OI connector on a different hubs. So this was the case till 1.42, and with 1.41 and the current architecture which I am showing, but with 1.42 and the recent certifications, we made the connector available on different secondary hubs, not just on the primary hub. So wherever you deploy the probe, it will basically create a required queues on the hub and then starts reading the data from the hub. Okay, and as you can see, like it reads data from the queue as well as it reads data from the UIMDB, and then it sends enriched alarm or a metric related info to OI. And as you may notice, two different arrows, but in real deployment, it's just an one connector endpoint, which is your APM gateway endpoint. Uh, and that will basically then send internally route the messages to Jarvis for storing an alarms into an Elastic, and to NAS for storing a cause and related metadata. With 1.32, the primary capability we added is storing the metrics in the NAS. NAS is basically a component on the OI that stores the metrics, and whatever the metric charts or the capacity analytics that you see on the OI side is all driven from the NAS uh, system. And in 1.32, we basically added a capability to store the metric data into the NAS. And there are, I mean, all other bullet points are basically pointing to what are the basic work done during this release. Like to store a metric on the NAS, we'll have to store a metadata first. Once you register a metadata, you get a unique ID, which is given away by NAS, and then use this metric unique ID to store the actual metric values, like the data series. And with version 1.38, we added a few enhancements related to capacity analytics use case supports, and primarily like uh, UIM, this probe used to push inventory and the CI, and even it can push alarms of up to Spectrum. So that integration is disabled with 1.38. So right now, if you look at the current release or any release after 1.38, the probe doesn't support publishing the inventory or the CIs to OI. And in the initial versions of 1.32, we used to push metadata, metric metadata to both the Jarvis and the NAS. This was required from the OI point of view because they need the mappings available in Jarvis to display the charts and all. So we used to push this metadata to both the systems, Jarvis and NAS, but with 1.38, OI has made changes to read this metadata directly from the NAS. So we removed the publishing of metadata to Jarvis with this version. And there were a few other issues which we fixed, like metric charts were not showing up for few probes, which we addressed within this version. There are performance improvements done with respect to the cache management within this specific version. Moving on to the next release, 1.39. So here, like there was an ask from the customer to filter the alarm. So till 1.38, OA connector is used to send all the alarms irrespective of its severity. So we added a filter on the configuration UI to send the alarms for the specified alarm severity. So you will get an multi-select list box, and from the list box you can choose like which severity category alarms you want to send to OI. So say suppose if you want to send only a critical or a major alarms, you can just choose those two options, and the rest of the alarms are just ignored or discarded by the probe. And with an alarms payload, so we have added a links for the operator console. So it will just give you an alarm endpoint to an operator console. So this payload will be used by the OI in the future to provide an landing page for when you view an alarm, raw alarm of a UIM in the OI, you can navigate back to the UIM using this link. So the initial payload is sent, but there are few other aspects. We still need to work on both the sides to get this fully done. Yeah, moving on to version 1.41. So in most of the customer scenarios, there is a difference in the number of alarms that the UIM shows and the number of alarms that are currently available on the OI side. So it all happens because like there could be some issues in processing an alarms, or there could be some issues with our cache management, or there could be issues, exceptions when the probe is running because of a threading model and all. Now with we have introduced a feature to reconcile alarms from the OI to UM. So if an alarm is closed in UM and but for some reason like the notification is not sent, or an alarm is updated on the UM, for some reason the latest update is not sent. So we basically reconcile or send that update, or for some reason like if an alarm is closed on the OI side, so we basically sync that status back into the UI. So this reconciliation helps us show a true picture of the UIM alarms versus what we have in the DXOI. This alarm reconciliation, you can configure an alarm reconciliation at an like an job, any job. You basically set up an alarm reconciliation schedule at a specified interval. Say you want to run this a daily, weekly, or every month, like that, and you can more or specify like at say I want to start this job at an late hours or a non-business hours. That you can specify along with the configuration, and that configuration is made available on the OIConnector configuration page from the admin console. Till version 1.41, we need to provide both the endpoints for Jarvis as well as NAS separately. So this is now combined, and users have to just provide one URL to the APM gateway. So if that URL is given, we probe internally derives the Jarvis endpoint and the NAS endpoint, and accordingly posts the data. Yeah, there was also like an feature available within the configuration to validate the connection to Elasticsearch. Basically, but in most customer scenarios, Elasticsearch URL is not accessible because like we don't expose Elasticsearch to the outside world. It's only accessible within our GCP environment, or within SaaS environment. So this check was available, but it was mostly like works for an on-prem OI versions. But later, like that was deprecated. Now we have altogether removed the Elasticsearch, the fields that collects Elasticsearch endpoint, as well as the connection test button menu item that was removed from the probe configuration. Now you can deploy this probe on all the required secondary hubs, and the probe does the job of reading data from the queues, and then it sends in enriched alarms or the cause to the OI directly without involving the primary hub's computing power. There was a small issue with respect to uh, alarm this is for an alarm reconciliation. When we read alarms from the OI, there were some limitations with respect to for reading a data in chunks. That was addressed with this release. Group subscription, which was an option earlier, is no longer part of this release. So all the groups and the inventory is now managed and sent by APM bridge probe, not the OI connector. So that probe has that single responsibility to send an inventory and the groups. But this option earlier we used to post the groups into Elastic, but this is now removed from the OI connector. With the final, which is our latest version, which is 1.42, it has all the abilities that were there in an earlier versions. Plus, we are now supporting in posting and data related to connector health. Like it says like the number of alarms or the number of metrics. Basically, it provides a statistics of the data we send to OI. So this is the compatibility matrix. In case if you are running an versions 1.41 or the latest versions, this is the compatibility. If you are using a 20.3 and OI should be always like it's a 21.x, because with 20.x like for reconciliation we use a specific endpoint, and that endpoint is not available with an older version of OI. So for OI we should always use 21x version, and whatever version you are using, for an example 24, for an example if customer is on 24.0, then we need web services rest, and this web services rest is needed only when you are handling a multi-tenant uh, configuration, when you are basically mapping our UIM origins to OI tenants. Otherwise, like this web services REST configuration is not required from the probe configuration. This is needed only in a case like where you want to send data to multiple tenants, OI tenants. And currently, like with the probe, there is a default tenant accepted. If you don't configure multiple tenants, the data is always posted on the default tenant. Okay, and with the versions 1.39 and older versions, it's the same configuration. The only change is again within OI version. OI version should be anything 20x or in later.